Hello medicos, welcome back to my channel. So today we'll be discussing about this very important topic under immunology, that is the complement system. So first of all, let's just know that the complement system is basically of three types, that is the classical complement system, the alternate complement system, and the lectin complement system. Right. So let's first discuss about the classical complement system. So under this classical complement system, what happens is that in our blood we have this C1 complex, okay, which is normally inactive, but when it binds to this antigen antibody complex, now here the antigen is the bacterial cell wall and antibody, so only two antibodies are basically involved in the activation of the complement system, that is the IgM and the IgG. Okay, these two antibodies are involved in the activation of the complement system. So when basically the C1 complex, it binds to the antigen antibody complex, it acts on C4 and it divides it into C4a and C4b. Now this C4b, it acts on C2 to divide it into C2b and C2a. Now this C2a and C4b is called as the C3 convertase. Now this C3 convertase will act on C3 to divide into C3a and C3b. So C2a, C4b and C3b is called as the C5 convertase. Now this C5 convertase acts on C5 to divide into C5a and C5b. Now this C5 joins with C6, 7, 8 and 9 to form the membrane attack complex, which basically causes cytolysis of this bacterial cell. Now let's just revise all of this with the help of a video.
Talk about steps of the classical pathway of the complement system. Here, the activated C1 in the classical pathway by antigen antibody complex acts on C4.
So here you can see that this is the C1. This is the C1 which is normally present in our blood, right? Now this C1, it binds to the antigen antibody complex. So this is the antigen which is the microbial surface, okay? And this antibody in the blood, that is IgG and IgM, which are involved in the activation of the complement system, they bind to the antigen surface. Now to this our C1q, which is C1q RS, it is called as, this is a C1 complex which is called as C1qRS, which binds to these antigen antibody. Now this, you can see here, it has now bind to C4 and it divides it into C4a and C4b.
It splits into C4a as well as C4b. So here C14b acts on.
Now you can see C14b, right? C1, C4b, it binds to C2 to divide into C2a and C2b.
C2, which splits C2 to form C2a and C2b. Now
this C4b and C2a is called as the C3 convertase, which will now bind to C3.
C14b2a is called as C3 convertase, which acts on C3, which splits into C3a as well as C3b. So here C14.
Now you can see C4b, C2a, C3b. This is the C5 convertase, which will now bind to C5.
B2A3B is called as C5 convertase, which acts on C5, where C5 is further converted into C5a and 5b. And C5 to C9 is nothing but called as membrane attack.
This is the membrane attack complex. We have C5b, C6, C7, C8, C9 membrane attack complex that will cause
complex
cytolysis,
leading to
right? So I hope you got a brief idea about the classical complement pathway. Now let's move on to the next pathway, that is the alternate pathway. So what is happening in the alternate pathway? Now in the alternate pathway basically, it is activated by the lipopolysaccharides, by the cobra venom, by the nephritic factor, the viral envelopes, the fungal cell wall, Ig and IgD aggregates. So all of these are involved in the activation of the alternate pathway. Now these are the microbes or the antigens that are just listed. So on this, C3 is present in the blood already. Okay, so C3, it is basically now it has now bound to the microbe or the antigen, right, to form C3b. Okay, now this C3b, it will basically bind to the factor B, which will divide into factor BB and BA. So now C3B and BB is called as the C3 convertase under the alternate pathway. Now this will bind to C3 to convert into C3A and C3B. So now we have C3B, BB, C3B, which is the C5 convertase, which will bind to C5 to convert to C5A and C5B. And after that, the pathway is just the same like the classical pathway. So under the alternate pathway, the C3 convertase is different. And the C3 convertase is what? It is C3B, BB. And what is the C5 convertase? It is C3B, BB and 3B. And which complement pathway is not involved? Which complements are not involved in the alternate pathway? So C1, C2 and C4, these are not involved in the alternate pathway. Okay, now let's move on to the next pathway, that is the lectin pathway. So under the lectin pathway, what happens here is that our complements, they will encounter what we call as the mannose binding. So this lectin pathway is also called as the mannose binding lectin pathway, right? Why do we call it as the mannose binding lectin pathway? Because here the microbe has these you can see here, this is the mannose. So microbe has mannose on its surface, to which are these complements, they go and attach to it, right? And after that, the pathway is just the same. It will bind to C4 to convert into C4A and C4B. So we have C4B. This binds to the C2 to convert into C2A and C2B. So we have C2. So C2A and C4B is the C3 convertase, which then binds on C3 to convert into C3 and C3B, which is now called as the C5 convertase, 4B, 2A and 3B, which binds on C5 to convert C5A and C5B. C5B and C5A, and then it is just the same. Okay. So here C3 convertase is same as that of the classical pathway, that is C4B and C2A, and C5 convertase is also just the same, that is C4B, C2A, C3B. Okay, and here C1, C2, here basically C2, C4 is involved, but C1 is not involved. So which complement not involved? C1, right? I hope you got a good idea about these three pathways, and I'll be just adding the link for the video which I just showed in this video. I'll be sharing the link for the same video in my description box. Do check that out. It's a good video. You'll get a much more better idea. But do revise this complement system. It's quite an important topic for your upcoming exams. Also, there are certain defects that we'll be discussing with respect to each of these complements, but that will be in our next video. Stay tuned. Keep following me for more such videos. Thank you.